Hello and welcome to this presentation for the Royal Horticultural Society's Level 3 Certificate in Practical Horticulture, brought to you by BEST. We're starting here a new topic, Topic 6, which is Protected Growing, and it's presented by Mike Roberts. So first of all, a quick look at the topic overview. This topic covers the principles involved in the design, selection and maintenance of protected structures. Protected growing involves the cultivation of plants in protected structures, which may include productive and ornamental spaces. To produce successful crops or displays, it's important to understand the characteristics of the different structures associated with protected growing, along with how growing environments influence health and productivity of plants. The impacts that internal structures and equipment have on plant growth are considered, along with the development of blueprints to produce crops and the principles involved in the management of small plant collections. So we'll kick off with element 1, which concerns the siting, design and maintenance of protected structures. As usual, have a quick look at the syllabus, and for AO1, the knowledge element, you'll need to know the range of protected structures involved in horticulture, including cold frames, polytunnels, conservatories and glasshouses. We'll consider the orientation and the siting of protected structures, and also deal with some of the maintenance requirements. For application, you'll need to know about the advantages and limitations of materials used in protective structures, and the benefits and limitations of polythene-clad structures. You'll also be required to maintain a range of protective structures. So we'll start with looking at the range of protected environments, and in gardening and horticulture these can take many forms, as we've seen from the syllabus: cold frames, polythene tunnels, conservatories, greenhouses and glasshouses. So we'll next take a look at each of these and consider some of the essential points about them. Starting with cold frames. Cold frames are useful in the garden to harden off plants, overwinter them, and sow seeds that need cool conditions, and also for rooting cuttings. Typically a cold frame is 45 to 60 centimetres deep, and the lid can be opened to varying degrees to control the temperature. They're not usually heated, but adding soil warming cables in a sand bed at their base can make them much more useful for propagation and for overwintering tender plants. Next, some structures which are widely used in horticulture: polythene tunnels, or probably more widely known as polytunnels. These are a cost-effective means of growing summer crops such as tomatoes and cucumbers. They can be a little unsightly and also uneconomical to heat and keep frost-free in the winter. But they can be used for growing winter crops usefully, and they're widely used on nurseries for propagation and for growing on. Polytunnels are available in a wide range of sizes to suit various situations. Small ones are suitable for allotments or for the domestic garden. The curved sides of polytunnels can sometimes make them difficult to work in, particularly up to the edge of the space. However, other designs have more vertical sides, which can make them more productive and easily accessible. Polytunnels needn't be single span. Modern multi-story, multi-span designs make them very flexible and extensive growing areas for commercial production. And they're now widely used for protecting otherwise hardy crops, but to get an earlier crop, such as in this crop of strawberries that we see here in the picture. A slight variation are the Spanish tunnel. These are hoops that are covered as a crop ripens and then removed after fruiting. This provides a rolling area of cover which, although unsightly, is an important aspect of agriculture in the UK and other countries, particularly for soft fruit production, for example strawberries. Some parts of Europe are covered with vast acreages of polytunnels and other glasshouse structures. Almeria in Spain has become Europe's market garden, and there are now an estimated 40,000 hectares of greenhouses and polytunnels in the Campo de Dalias, the largest concentration in the world. Polytunnels have many advantages, including they offer a lower cost per square metre compared to traditional structures such as glasshouses. They can be assembled more quickly and easily than glasshouses and can be relocated if necessary. They're available in flexible sizes and can span up to 30 feet or multiples of this. They provide excellent light transmission and diffuse light effectively. The sizes of doors can be customised, and both overhead and direct irrigation systems can be installed with ease. They offer significant protection against wind, snow and rain, and it's easy to fit side and end ventilation. And finally, they create fewer drafts, though careful ventilation is required due to this feature. There are, however, some significant limitations. Tunnels tend to have lower temperatures inside compared to the outside during frosty conditions. They're more difficult to shade than glass, for example with spray-on shading treatments. Tunnels are also more susceptible to wind damage during severe weather, particularly with plastic coverings being blown away. They're also more likely to collapse under the weight of snow compared to glass houses. And finally, polythene films have a shorter lifespan, which incurs replacement costs. Next, a quick look at conservatories. And a conservatory is an extension to the house usually, and a step up from a lean-to greenhouse. They're more often seen as an extra room rather than a growing space, and consequently conditions that make the conservatory habitable for humans are not often conducive to plant cultivation. During the Victorian period, conservatories gained immense popularity as innovative materials and technologies allowed for intricate designs that became essential for affluent middle-class families. By far the biggest area that we need to cover in this topic are greenhouses and glasshouses. Greenhouses can be clad in many different materials, whilst glasshouses only have glass glazing. There also tends to be a feeling that greenhouses are more associated with the domestic amateur gardener, while glasshouses is a more professional term for commercial growing. Apex roofed greenhouses are the most common type of freestanding glasshouse for domestic gardens and also for commercial use. But there are many other innovative designs that have appeared over recent years, including circular, pyramidal and geodesic domes. A typical apex glasshouse, sometimes referred to as a Dutch light, has glass to ground level glazing. This allows for maximum light transmission and is ideal for growing taller crops, for example tomatoes and cucumbers. Angled sides allow for greater light transmission in northern latitudes, where the sun never climbs as high in the sky as in more southern areas. Brick-based designs were very popular in recent years, and they're more costly to construct, but offer greater insulation. These are useful where plants are grown on staging rather than into the ground. They can also be sunken into the ground for greater insulation purposes. As we've previously seen, there are some very novel and innovative designs for glasshouses, although these tend to be mostly concerned with domestic or private gardens. This revolving glasshouse allows for a cultivation of a small range of crops. It also rotates to get the maximum amount of sun for each plant. Octagonal structures make impressive garden features, and geodesic domes offer a space-age look for a garden. Small walk-in greenhouses are suitable for small domestic gardens. Sunken glasshouses are also a possibility and were very popular in Victorian and Edwardian eras. The sunken glasshouse offers good insulation from the surrounding earth and were traditionally used where plants were grown on benches rather than in the ground, examples being specific orchid and alpine houses. For commercial growing, a typical greenhouse needs to be much larger, and the Venlo greenhouse is probably the most well-known type of greenhouse amongst professional growers. This design has proved to be the most economic greenhouse structure suitable for all crops in most climatic conditions. Whilst many glasshouses can be very utilitarian and not particularly attractive to look at, it should be noted that glasshouses have widely been used in botanic gardens and other attractions to provide a centrepiece of horticultural excellence. These date back to the Palm House at Kew Gardens, and a more futuristic design also at Kew Gardens, which is the Princess of Wales Conservatory. Impressive domes can be seen at the Welsh Botanic Garden and also at the Eden Project in Cornwall. Next, we need to consider siting the glasshouse. For a domestic glasshouse, it needs to fit in with the constraints of the overall garden design. But commercial glasshouses need to be efficient and have good access for deliveries and dispatch. For both amateur and commercial glasshouses, the following are very important. Essential factors include shelter from the wind. Excessive wind will lead to cooler temperatures and more increased need for heating in the winter. Exposure can also damage delicate structures such as polythene. We need an open site to maximise the amount of light away from shade, unless of course the crops we're growing are more shade tolerant. We'll need access to get in and out of the glasshouse, and we may need proximity to services. This is going to be essential for a commercial greenhouse and desirable for an amateur greenhouse. We may need gas for heating or electricity and a supply of water. The aspect required for a successful greenhouse or protected structure: an east-west orientation, that is with the ridge running east to west, will slightly extend light levels during winter. This reduces the amount of supplementary lighting that may be important for photoperiodic plants, such as natural season and all year round chrysanthemums. A north-south orientation is suited to summer crops such as tomatoes, with both sides receiving several hours of sun from the east and then from the west. With this orientation, the end timbers or structure will reduce the amount of sun reaching the house during the hottest midday period and reduce the possibility of damage to the crop. In this illustration, we can see some different locations for a glasshouse in relation to a domestic dwelling. Important to site the glasshouse away from the building itself. This first area has a poor location, gets some shade during the day as it's on the north side of the structure. Whereas moving the glasshouse to the south means it's an excellent location, never in the shade. Situating east or west in relation to the building will mean it's a good location as well. It'll get some shade earlier in the morning or in the afternoon. We next need to consider the materials from which protected structures are made from. And protected structures can be constructed from a range of materials, including steel, aluminium, timber, plastic, and additionally the cladding can be glass, polythene and specialist films, acrylic sheet, and twin wall polycarbonate. So we'll briefly take a look at each of these. Firstly, steel. Steel has several advantages, including it's very durable, especially if it's galvanized. It's very strong, which means that you need fewer supports, and this in turn will increase light transmission into the protected structure. There are several limitations, however. It's very heavy. It's got poor heat retention. It can rust, especially if not galvanized, and tends to be quite expensive. Aluminium is a popular material, especially for the domestic market. It has several advantages. It's almost maintenance free. It doesn't rust like steel, although it will corrode. It tends to be very lightweight, cheaper than wood, and easily extruded to make very complex parts. Limitations include it's not as strong as steel, so therefore more struts are needed, and this has a knock-on effect on the light transmission into the structure. It's not a good insulator and tends not to look particularly good in domestic gardens unless it's powder coated. And although it doesn't rust with steel, it does corrode with age, and this means that nuts and fixings can seize up over time. Next, wood. Advantages here include it's attractive, which is particularly important for a domestic amateur garden. Timber is also a good insulator, which can help with energy costs. and it can also be very sustainable, especially if the timber is sourced from a Forestry Stewardship Council source. Limitations include a reduced lifespan. For example, pressure-treated timber will have a 15-year lifespan or thereabouts. Some timbers have a longer lifespan than others, for example, oak or cedar. Timber tends to be weaker than metal, and this means that we need wider glazing bars to sustain the weight, and also more struts. And this has, again, a knock-on effect on less light transmission. There's also the need for rather more maintenance than would be associated with a metal structure. Plastic is also used for conservatories and for domestic greenhouses. Advantage here is PVC is fairly low cost compared to other materials. It's also very lightweight, easy to assemble, but on the other hand, tends not to be very rigid, limited heat loss, and will degrade in sunlight, particularly ultraviolet light. A larger frame may be required because of the strength issues, so again, less light transmission. Moving on to look at cladding materials, first of all starting with glass. Horticultural glass, standard thickness is 3 mm with light transmission of 90% plus and fairly good at excluding ultraviolet light. Toughened glass to BS 6206 grade A is more common. It has added strength and safety. 3 mm and 4 mm are used in glass houses, frames and cloches. Advantages include good heat retention, excellent light transmission, and very long lasting, particularly if toughened glass is used. Disadvantages include the fact that it's heavy, so glazed structures will require stronger glazing bars and internal structures. It can be easily broken, particularly if we go for standard horticultural glass, and relatively small panes, although modern toughened glass can be much larger. Polyethylene film or polythene, used for polythene tunnels or polytunnels and also for insulation within glazed structures. Advantages here include that it's flexible, it's a very cheap material, available in many thicknesses, and diffuses light. Disadvantages, it breaks down, particularly in ultraviolet light, in 3 to 4 years, though more recent forms are more UV stable. This of course means that polythene would have to be replaced on a more regular basis. It does have lower light transmission, particularly on the thicker grades of plastics, and doesn't retain long wave heat. It attracts dust through electrostatic action on the surface of the polythene. And of course there's an environmental effect, that it's single-use plastic, and what do we do with the plastic once we need to reclad the polythene tunnel? In addition to polyethylene, there are also many specialist plastic films used for cladding polytunnels. Newer grades of plastics are available commercially, which are light diffusing, anti-fogging to reduce condensation, and can give better light transmission than glass. Solar EVA 5HD, for example, claims a 92% light transmission level with 70% diffusion. Other films control the amounts of far red and near red light passing through by reflecting some wavelengths which are not used for photosynthesis, and this in turn helps to reduce heat build-up in polytunnels. Acrylic sheet can also be used. The advantages here include high light transmission rate, even higher than glass with some types. It's lighter and stronger than glass. Flexible and safe, meaning that it's very tough, and can also be shaped to create some innovative designs. Disadvantages include poor heat retention, and it will degrade with light over time and gradually yellow and become cloudy, which in turn lowers the light transmission. It can also be relatively expensive compared with glass. And finally, polycarbonate or twin wall. These are rigid plastic sheets used in greenhouses, clochers and frames, and also in conservatories. Twin wall polycarbonate sheeting provides some level of insulation, at a cost though in light transmission. So light transmission is reduced down to 76 to 80%. Life expectancy can be between 10 to 25 years. Advantages include large sheets are available, it's very lightweight, it's versatile and less brittle than glass, which makes it a lot safer. There is some heat retention, but disadvantages include the fact that it is expensive, as we've mentioned, lower light transmission than glass, harder to clean, and there can be condensation problems. And finally, shade netting. This can be used to cover clochers, polytunnels for growing shade-loving plants such as ferns, hostas, etc. Advantages here is that it's reusable, light cover to shade cold frames and greenhouses. It's cheap, can be used as a windbreak as well to reduce plant stress. Lightweight, useful for tunnel sides to allow ventilation in summer without allowing in animals. Disadvantages include it needs to be removed manually when light levels are reduced, for example in winter. And there's also a cost here that it's plastic, and so what do we do at the end of its life? So moving on to the maintenance requirements of protected structures. The maintenance requirements of different structures will differ depending on the materials that they're made from. There is, however, one common element no matter what the structure, and that is cleanliness. Cleaning structures, whether glass or plastic, greatly improves the growing environment for plants. By removing the algae, moss and grime, it lets in more light and helps control pests and diseases too. Many pests and eggs may overwinter in crevices, and fungal spores will be present on dead plant material and on the structure itself. Cleaning is best carried out when appropriate for the plants being grown. For summer cropping, for example tomatoes, we can clean our structures in late autumn or early winter when the crop has been cleared. For all year round plants, for example orchids, clean in mild spells in autumn to improve light transmission as winter approaches. For periodic and successive crops, for example raising seedlings, clean in periods between crops such as late autumn or early spring. The process for cleaning a protected structure involves removing plants first of all to a sheltered area for protection while the cleaning process is in duration. Next, brush or vacuum the insides to remove all debris, making sure that you get into all the nooks and crannies. Clean the structural parts with a suitable horticultural cleaner, such as Jay's Fluid, Just Glasshouse Cleaner, Citrox, or Polytex Pro. This is particularly useful for plastic surfaces. The glazing material should also be washed inside and out, but for plastic materials, test on a small area first to be sure the cleaning material doesn't damage the glazing. Scrub off any old shade paint on the outside of the glass if this has been used for shading in the summer. And ease out dirt trapped between panes using a flexible scraper. Pay attention to propagation areas and equipment. Young plants are especially vulnerable to disease. Clean out any gutters and water butts at the same time. If a specific pest problem has reoccurred, it may be prudent to fumigate after cleaning using a proprietary greenhouse fumigator. Timber structures. In addition to routine cleaning, it's recommended that timber frame structures receive regular preservative treatment. A wide range of products is available, including stains and preservers, natural oils, including linseed oil and teak oil, and a wide range of coloured stains and paints which are particularly appropriate to domestic gardens where colour themes and effects are required. Refer to individual manufacturers' guidelines to ensure a product is suitable for the timber being treated. And lastly, in this presentation, we'll just consider very briefly the integration part of the syllabus. And this states that you need to be aware of the impacts of siting, design and maintenance of protective structures, and these are considered in reference to plant health and sustainability. We've dealt with a lot of these issues as we've gone through this presentation, but just as a recap, plant health and requirements. Light is obviously required for photosynthesis, so light transmission into the protective structure will be critical. Too little will reduce photosynthesis, while too much causes overheating and scorch. So we need to consider the orientation and cladding material. Additional shading may also be required through either the use of shade netting, thermal screens or shade paint. Temperature is another critical factor for plant health, and siting the glasshouse in a sheltered situation will reduce exposure that may cause damage and require supplementary heating. Consider insulation properties of the structure and the cladding. And finally, ventilation. Adequate air circulation is required for photosynthesis, in particular carbon dioxide and oxygen for respiration, and also to help minimise disease. And here the structure needs to consider the number and position of ventilation points. We also need to consider sustainability when we're considering protected structures. In both the design, we need to these days be very conscious of energy efficiency. So by considering the insulation properties of materials, we can hopefully reduce heating costs. The situation, maximising natural heating from sun and reduced use of artificial heat sources. The structure, we need to consider the carbon footprint of materials versus their lifespan. This isn't always clear cut. Steel and aluminium requires vast sources of heat in order to produce, but is very long lasting, whereas some other materials may be more environmentally friendly in the short term, but may not have as longer lifespan and require replacing on a more frequent basis. This also applies to cladding materials and the debate versus glass versus plastic. So, nearly at the end now, so what next? As usual, further information in your course notes, including a more in-depth look at glasshouse design and construction. Topic 6, Element 2, looks at internal structures and the equipment used in protected growing. So that brings us to the end of this presentation. Once again, thank you very much for listening. We hope you found it useful and look forward to seeing you again in another presentation. So this is Mike Roberts saying goodbye for now. Bye-bye.